Hello guys, welcome. We are
Yeah, she messed it up. Yeah, guys, welcome once more to our YouTube channel. So just pause the video here, guys, and then check out the problem. Okay, if you can attempt it, if you can solve it, that's perfect. If you can, you will check out what we've done eventually. Let's go. Okay, so we have two events A and B as such that P of A equals this, P of B equals that, P of A given B is that. Find P of A intersection B, the probability that neither A nor B occurs. Okay. So the first part is we want to look for P of A intersection B, but we know how to get P of A given B. Well, P of A given B is P of A intersection B over P of B, right? So we can make P of A intersection B the subject. And that is equal to P of A given B multiplied by P of B. And so P of A intersection B is 1 over 5, which is P of A given B, right? Multiplied by P of B, which is 1 over 3. So our P of A intersection B is 1 over 15. Easy peasy, lemon squeeze A. So B says the probability that neither A nor B occurs. Well, P of neither A nor B is actually 1 minus P of either A or B, right? And in probability, when you're able to find the probability of an event by getting 1 minus the probability of another event, then this event is basically the complement of this event, right? Good. And so you realize that we can write P of neither A nor B is simply what? The complement of P of either A or B. So A or B complement, all right? So that's what this is. Equals 1 minus. Now, what's P of either A or B? That's P of A union B, right? And how do you write P of A union B? Is P of A plus P of B minus P of A intersection B, right? Perfect. And so you realize that, well, our P of neither A nor B is equal to 1 minus all of these expressions because our P of A is 8 over 15, our P of B is 1/3, P of A intersection B is 1 over 15, and so our P of A union B, or that complement, is of course 1 over 5. And there it is, guys. Let's move on to the Roman 2 part of the probability problem. Okay, guys, so here's a problem. It says a spare part dealer receives spare parts from three different suppliers, X, Y, and Z, with 2 over 5 of the parts coming from X, 7 on 20 from Y, and the rest from Z. It is known that 2 on 25 of the parts supplied by X, 110 supplied by Y, and 1 on 20 supplied by Z are defective. If the spare part is bought from the dealer, find the probability that the spare part is A defective. Okay. So we can draw up a tree diagram to represent all the what is happening here, selection process, right? So we can get a car part from either car from supplier X or supplier Y or supplier Z. To get a car part from supplier X, the probability is 2.5, like the examiner gave you here. To get it from supplier Y, it's 7 on 20, and then the rest from supplier Z. So how do I get that probability of getting a car part from supplier Z? 1 minus the probability of this plus this, right? That gives me 1 over 4. So I can go over and then talk about the probability of now getting a defective car part from supplier X. So remember the examiner said, my mom calling, sorry. So it is known that, so 2 on 25 of the parts supplied by X, so those are above the probability of getting a defective car part, right, from supplier X. And then a non-defective car part will simply be 1 minus probability of getting a defective car part from X, which is 23 on 25. And then defective car part from Y is 1 on 10. Non-defective will be 9 on 10, right? Defective for Z will be 1 on 20, and a non-defective will simply be 19 on 20, right? Just 1 minus 1 minus, you see the other. All right, so you recognize that we have a complete setup of what is happening. We can now go and talk about how do we calculate the probability of getting a defective car part in this experiment. Well, this is the truth. The defective car part can either come from supplier X, or it comes from supplier Y, or it comes from supplier Z, okay? So what this means is I can get, for all the car parts from supplier X, I can get some that are defective, or I can get car parts from supplier Y and some are defective, or I get car parts from supplier Z and some are defective. So we just need to transfer, or we need to translate that grammatical statement into a mathematical probability statement of probability distribution, really. And what we have there is probability of defective uh, car part will be probability of okay, getting a car part from X and it's defective, okay? Or getting a car part from Y and it's defective, or getting a car part from Z and it's defective. So getting a car part from X, the probability there is first of all 2 over 5, and it's defective. You multiply that with 2 over 25. Y and it's defective, so 7 on 20 and 1 on 10. Z and it's defective, 1 on 4 and 1 on 20, right? And so you realize that we have this probability is 159 over 2000. Now, you must be wondering why I'm just simply multiplying the intersection of these two events. That's because these two events are independent, okay? A very good example of this would be when you're getting a selection of a ball from a box of balls. So let's say the box has green, yellow, and red balls, and you're supposed to pick one ball at random. Now, the event of you actually picking a ball from that box is independent to what? To the color of the ball, right? So the event of you buying a car part from a dealer is independent of whether it's defective or not. Okay, good. So we can go over and then now talk about the probability of either from Y or it is defective. Okay, so we're just going to use the normal probability statement for defining either or cases, which is basically a case of union, right? So probability of getting a car part from Y or just getting a general defective car part minus the probability of getting a car part that is defective and is from Y. That's really what this is. So you realize that that probability right here would be probability of getting a car part from Y is 7 on 20, right? Probability of getting a defective car part would basically be what we've calculated here, 1 over 159 on 2000, minus the probability of getting a defective car part from Y. This is what this means. And what's the probability of getting a defective car part from Y? It's just 1 on 10, all right? Or you think about it like this, the intersection of uh, car parts from Y and overall defective car parts in this experiment, what's going to be that intersection? Well, the intersection is basically going to be the defective car part that can come from Y. All right. So the one mistake students would do here is that they would interpret this probability as if it was this probability here, because notice how they are represented the same: P of Y intersection D, P of Y intersection D. But this is defective car part from Y. Okay. This probability of getting, all right, so I need to go to Y first before I find a defective car part, right? But over here, we're looking at the intersection of overall defective car parts in this experiment, and then you getting car parts from Y, right? And so that intersection, you realize that will simply be the defective car parts from Y. Perfect, which is 1 on 10. If you don't get this, just leave questions in the comment section. I'll make sure I can explain through a write-up. I think that will be clearer. Now, we can go over and then substitute this and then simplify. We get 659 on 2000. We can go over and then talk about C, which says from X, given that it is not defective. All right, so probability of getting a car part from X, given that it's not defective. So we interpret that like that, all right, given that probabilities. So this probability of not being defective down here is easy because we found the probability of defective. So probability of not defective simply be 1 minus probability of defective, right? So the numerator now says probability of car parts from X intersecting with the event that we are getting defective car parts in this experiment. And that would simply be what? That would simply be the defective car parts that come from supplier X. And what are the defective car parts that come from supplier X is simply 23 and 25. Again, don't make that error here of getting the event of X, right? 2 over 5, multiplying that with the event of defective car parts, which is multiplying it with 1 minus this. That's nonsense, right? Because at the end of the day, it simply just gives you the probability of X. Yes, if you do that, it would simply give you the probability of X at the end of the day. All right, so that's what we do. And then we go over, another mistake a student can do here is that it comes here and it says, all right, probability of getting a car part from X and it's defective. So you simply take 2 over 25 multiplied by 2. That would be terrible, okay? That would be wrong. All right, so you're not really interpreting the fact that, hey, we are talking about just getting a car part from X, or it is generally defective in the whole experiment. All right, so this is an entire experiment. It's not just talking about X. Good. So that is 23 on 25 there, and you do that probability is 1840 over 1841, and that is our result. All right, guys, I think that's the end of the probability question. I hope you liked it, and if you have any questions, drop them in the comment section down below. I can't wait to read them. Thank you so much. Stay curious always. See you in the next episode.